All right, so this is lesson 2.1, 2.1. As soon as I get it on the board. All right, here we go. Let's start off chapter 2, distributions, and let's rock it. Okay, so describing a location in a distribution. The distribution we're going to be using is the normal model that we kind of watched that little video on today. This only works with a normal model because we're using mean and we're using standard deviation, and you only can use mean and standard deviation when you have a unimodal symmetric bell-shaped curve. Okay, so if you notice on your purple packet, we're going to be in table A, but if you look at the very, very top of table A, it has a normal model at the top. It does not have a skewed distribution at the top. So at the top of it, it does have a normal model. So that just tells you this can only be used when you have a symmetric unimodal bell-shaped curve. Okay. All right, let's rock on. All right, so what we're really going to start with is something called the density curve. And you looked at it yesterday when y'all were matching. Okay, you had these little curves, and they weren't a histogram where you had a bunch of bars. A density curve is just like the smooth shape that would go on top of the histogram, and it makes it more pleasing and easy to our eyes to be able to see what the shape of the distribution is, okay? So we're going to be looking at the density curve. The density curve is always on an x-axis and always has an area of 1 underneath it every single time. Okay, it has an area of 1. Now, it can have any type of shape to it, okay? It could be bimodal. It could be that beautiful bell-shaped. It could even be rainbow-shaped. And my favorite is uniform shaped. It's consistent all the way across, okay? So it can be a variety of any of these. This is the one that we love and we're going to use a lot, the normal model. Okay, it's the bell-shaped curve. It's not a rainbow, it's a bell, okay? So it's a bell-shaped curve where it tails off on either end. This is called a uniform model, and I love the uniform model because it brings me back to geometry. The way that you find all of the area underneath a uniform model is area equals base times height, okay, or length times width. Where if I'm using a normal model, then I'm going to have to end up using my z-score table. Okay, it's called my normal table. Okay, so if it's anything other than that, if it's skewed or has outliers, then yes, we'll be using median and IQR. We're going to put median and IQR to the side for a little while though, okay? All right, so relative standing. So this is very important. If you're looking for your relative standing, we need to normalize our data. So like we were talking about SAT scores and ACT scores, I can't compare apples to oranges. I need them all on the same scale. So that's why the z-score table was invented, is because it gives me a middle of 0 and counts up 1, 2, and 3 and down 1, 2, and 3. And so what it does is it puts you, it's called a normalized or a normal distribution. So instead of me putting, the average SAT score as 1100 right there, well, I can't really compare that to the average SAT score or ACT score of 26 or whatever it might be. So what we do is we scale them out so that you're on a scale of 0, 1, 2, or 3, and negative 1, 2, or 3, okay? So that is what our normal curve will be, okay? All right, so there are standardized values, All right, and a z-score, I've already shown you that formula. Make sure that you do have your z-score formula written down. So it is your x minus the mean divided by standard deviation. Essentially, that's it. The way I like to think about it is x is your score. That is the score that you are trying to test. Your mean, they'll give to you. Your standard deviation, they'll give to you. Your z-score always needs to be rounded to 2 decimal places because your table A in the purple packet is to 2 decimal places. So you need to round this. We're not truncating. You will round up or down. Go to the 3rd digit, round up or down, okay? And that is our z-score. And your z-score is, the way I like to think of it is, it is your personal standard deviation from the mean. we're talking about your personal information or whatever the data is that we're trying to focus on, okay? So if we're trying to look at your average versus the class average, okay? What was your test score versus the class's test score? And then we'll divide it by the standard deviation of the class, okay? And then we'll figure out where you fell on the curve, okay? All right. So that is how you found your personal standard deviation from the mean. All right, again, here's our 68, 95, 99.7 rule. This is for heights of women. So if you are a lady and want to look at where you might fall, you can kind of see where you fall. I fall within one standard deviation. I am 63 inches. So Mama Hightower falls right about there. So I'm within one standard deviation of the mean. So I'm pretty average. Okay? But if you wanted to look at Miss Scott, who I always like to bring up, Miss Scott might not be within one standard deviation of the mean. And if you fall outside of two standard deviations, we don't necessarily call you an outlier, even though we use that term very loosely. It's more unusual for you to be that way, okay? What was Coach Stone's daughter's name? She was so tall. Taylor, she was tall, okay? And I don't even remember when she graduated. But so she was tall, so she might be on this end of the spectrum, right? Was it Rashad Patel, maybe? Rashad? Was he super tall? Do y'all remember he was here a few years ago? Javed, yes. Okay, yes. He was in my class, and he had like a size 15 shoe or something. I loved having him as an outlier. Huh? Oh my goodness, he could have been our outlier. Okay, so anyhow, this just gives you an idea, where do you fall away from the center, okay? Your standard deviations, 1, 2, and 3, 68, 95, 99.7. Go ahead and memorize that. It'll be easy for you to memorize, okay? This is our standardized value. Like I said, it is your score minus the mean divided by the standard deviation. Round to 2 decimal places on that. And let's do a few examples. All right, here we go. We have 25 kids' test scores. I gave you a mini tab output. Don't forget how to read these computer-based outputs. Here's all the data right here. So this is our sample size, the number of observations we have. Our mean and our median are the same. Is that important? What does it mean? Symmetric. Very good. Okay, so unimodal symmetric. If we look right here, we have our min, our max, Q1, Q3, and median. So we have our 5-number summary. Okay. When it says numerical summary, remember, you decide which numerical summary do you need to use. Do you need to use median and IQR, or do you need to use mean and standard deviation? We're really going to stick with the last one, okay? All right, so we have all of our information here. I'm going to go ahead and write it down that our mean is 80 and that we have a standard deviation of what? 6.07. All right, so make sure you get used to reading these, and now we're just going to do a few Z-scores and see how people do, okay? All right, here we go. Jenny! I always think of Miss Peyton. All right, Jenny. So, Miss Peyton made an 86 on the test. Where does she fall relative to her classmates, okay? All right, so if we look at this right here, we know that she's above average because the average was 80. So what we're going to do is we are going to find her Z-score. So on this paper down here, we can go ahead and find it. Z equals your score. We're looking at Jenny's score. Should say Jenny at the top. Sorry it printed out so dark, y'all. I thought I was doing something great by doing a cute background, and now y'all can't write on it at all. And then I thought it was even better that I was making the slides bigger for you so you could read them better, yet you have no room to write on your paper. So I apologize. Look, it was all in good, like from a good place. All right, so her score was 86, and we're going to subtract the mean 80, and then we have 6.07. Again, be careful. Use one of your little calculators to do this, because if you don't, it will, remember, divide before it subtracts. It's going to do PEMDAS operations. So if you don't put parentheses around this or use a fraction bar, it's going to do 80 divided by 6.07 before it subtracts these. But we know that's not what we want, okay? So either use the little calculator or use parentheses in your big calculator. And we round to 2 decimal places, and what do we get? 0.99. So she has 0.99 standard deviations above the mean. So she's not quite 1 standard deviation, but she is above, okay? Now, there are a few different ways of finding percentiles. I don't know if I'm gonna, okay, there's one way. This is a very easy way. I could go back. I'm gonna scooch back, maybe it'll let me. All right, how many people fell below Jenny? We could do a very quick percentile. How many people fell below Jenny? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Did I miss one? I marked 90? 21. All right, did we get it? All right, so 21 out of how many students? So 21 out of 25. This is a quick percentile to tell you like her ranking, right? So do that in your calculator. Is it 21 out of 25? It's, whoa. All right, so it looks like she's about in the 84th percentile. And all that does is just show her that about 84% of the people fell below Jenny. Another way you could do it is at or below, and it's just done either way. So when you're looking at that percentile, I could have added Jenny in there and done an 86, and it would have changed it a little bit, and that would have been at or below versus below. Either way is commonly used, okay? Now, this isn't the best way of doing it, but that is a quick way of seeing where you rank, okay? That is like your ranking there. Now, what I would like you to do is get out your purple sheet. So get out your purple paper. And let's fold over to table A. And we are going to look at how Jenny did with the normal standardized distribution, okay? Now, when I look at Jenny, when I always love to look at a picture. When I look at Jenny, then I know that this is 80, and I know that she's at 86, and I know that if I were to count up one standard deviation, that one standard deviation is at 86.07, right? Now, do y'all see that this mean cuts it into 50%? So I know that I have 50% right there, right? And I know that if one standard deviation out is 68% in both directions, cut that in half. What's half of 68? 34%. So, on this end. So if this is 34%, 50 plus 34 puts her about at the 84th percent-ish. And what did it put us over here? That's kind of good, right? Okay, so we're doing pretty good. But we can actually be more exact than that. So I want you to go to your Z-score table. Okay, do you remember how to use it? We're going to cut up. We have our hundreds decimal over here at the very, very top. So we need to go to the positive. Make sure you're on a positive Z-score, which means you're on the back of the paper. And now look at your Z-scores to the left, and they should all be positive numbers, okay? And we're going to go to 0.9 on the left side, 0.9 on the left side. And then we're going to go to 0.9 at the very, very top. And then you're going to bring your fingers together until we get to the decimal that it goes with, okay? All right, so 0.9 and all the way over. And did y'all get 0.8389? Yeah. Okay, so you should have gotten 0.8389. All of these numbers are looking pretty good, aren't they? Okay, so if you look at that, if we were to, that's put us in the 83.89 percentile. Now, that's pretty good. So you can see how all of these, empirical rule is a great estimation, but it is still an estimation. It's working out really well for us in this situation. Do you know why? Because we're so close to one standard deviation over, right? 0.99 is really close to one standard deviation over. So it's working out really well that this number comes out to be the same as this number right here from our table, okay? And again, you can use percentiles as well. So those are just a few different ways of looking at the percentiles. We'll use the table for the most part. We don't use this. This is such a rough estimate. You'll see it. We'll do it a little bit, but it's not commonly used. All right, Katie made a 93. Go ahead and find out Katie's Z-score. Round it to 2 decimal places, and what do we have? 2.14. All right, so because it comes out to be a positive number, that means that she is above the mean, which you can tell by her score, okay? All right, next, Norm. All right, Norman, figure out Norman's Z-score. He made a 72. Is he above or below average? He's below average, so he should have a negative Z-score. We're going to the left of the mean. All right, round to 2 decimals. What did you get? 1.32, below the mean. So his Z-score came out to be a negative 1.32. I did not write the negative right here just because I wrote the word below, so I didn't have to write the negative. So he did really terrible. I want to know what his percentile is. So I want you to look at, we call it a p-value. When you look it up on the purple table, on the standardized normal curve, we call it a p-value. So I would like to know what his p-value is. And that just helps me understand that I'm not just using, a fraction to come up with what his is. His is negative. Make sure you turn to the negative. So what are you going to look up on the left side? Okay, negative 1.3. So we're going to go on here, and over on the left side, we're going to go to negative 1.3, and then you're going to go over to 0.2 at the top. And what did you get? 0.0934? Yes. All right. So his p-value is 0.0934, okay? That puts him in the 9th percentile. That's rough. You did not do good. That means only 9% of the people fell below him. Okay? Norman, let's do better next time, okay? All right, so that just gives you an idea. Again, we use it for comparison. So let me see. Let's go to this ACT, SAT. I like this one right here. All right, so 2.1, go to the ACT versus SAT, and then we're going to kind of finish right there, and I will pick up on Tuesday, okay? Do not forget that you do have homework tonight, and you have all weekend because you have Monday off, okay? So look at the back of your unit plan that I have for you, and you have 1, 2, 3, 4, you have 5 problems, okay? All right, and if you can't get through all 5 of those problems because I'm not finishing the lesson, that's okay too, okay? All right, so Ellen scores a 680 on the math part of the SAT. The distribution is symmetric, single peaked with a mean of 500 and standard deviation of 100. Gerald takes the ACT and makes a 27, where the ACT is symmetric and single peaked with a mean of 18, standard deviation of 6. Who did better? Let's go. Ellen. So get on your paper and let's mark Ellen and let's mark Gerald and see. So here we go. How are we going to do this? That's right. Let's find their Z-scores. All right. Ellen's score minus the mean divided by the standard deviation. Gerald. Do you have to find the p-value to determine who did better?
No.
No. Who did better? Ellen, very good, okay. If you wanted to look at their ranking and their percentile, then yes, you could absolutely look up the p-values for that and drive it home that Ellen did better, okay? So again, this is another way of looking at your, this is again called the empirical rule, and the empirical rule is an estimation. It is an estimation. If you actually fall exactly on one standard deviation, you might find out that it might just be, a few decimal places off from actually being what it would be if you added all of these up, okay? So just know that it is an estimate, okay? That is your Z-score summary. All right, again, this is a way that I was talking about your percentiles. You can take all the numbers that fall below you, or you can do the ones that are at or below you, just like we did with Jenny's, okay? So that is a way of doing is finding percentiles. Again, when we find a p-value if you find a value from the table, we call that a p-value. And yes, it will be more exact than just finding a percentile, okay? All right, the next thing, okay, we already did one, so I'm not going to do that. Again, there are different ways of finding percentiles, like I said. So now moving on to table A, I've already shown you that. That will give you something called a p-value. It's a precise percentage, probability, all of those words, proportion. Okay, that's why I call it a p-value, because it's like probability, percentage, proportion. So I just call it a p-value, and that's what we'll call it throughout, okay? Now, I want you to mark out Chebyshev's inequality. I will confirm this again, but they made changes last year to this year. So this is my first year with the new AP Stat changes. I do not believe that Chebyshev's inequality is in it. If it is, and I'm going to dig a little bit deeper, I've already emailed College Board about it just to confirm. It's not in any of my AP curriculum, but I hate taking something out until I have like it written down, you know. So I will go over this if I need to on Tuesday. So if you see any questions on your homework that deal with Chebyshev's, just skip over it, okay? Say, Hightower, I'm not going to do number 12 because it's Chebyshev's. And I'll mark out 12 for everyone, okay? Because I did not go back and do that until I confirm that, okay? All right, so we're not going to look at Chebyshev's. We are done for the day. You do have a little bit of time in here if you'd like to look at some of the problems in the book. And that's pretty much it. Good job today, y'all.